Hello guys, I'm live again. This is with Prakash Das. Yesterday we left here with the promise that we will be live. I will be live again with all your queries, all your problems, whatever you have with you. And I am specially doing the special theory on physics preparation for JEE, JEE Main, JEE Advanced, and so on. In the last class of class 12 discussion, I was discussing regarding the magnetism and magnetic effect of current, and today I have come here with, you can see from the banner above that it is pointing towards the comprehensive study on specifically the circular motion, that is the rotational dynamics of bodies. And with that concept, let us start today's session. Previously, two sessions has been already carried out. As I informed you that my previous live sessions were happening in the were happening uh, in the on Facebook. So it is quite obvious that I was actually connecting to you for with the intention that you might get interested about certain study of just give me some time to have some audience from your side. I am audible, right? If I am audible, okay. So thank you for your response. A lot of students are really very much interested about my session. I got the information that uh, so today I will discuss different circular motions. So before that, okay, so okay, so that's a very interesting topic I'm going to cover today, and with much more practice on MCQs as well. Okay. Mm, okay, so you are free to connect me through the comment section over here, given over here. So let us start today's session without spending much more time. So I was actually looking forward to make you understand all the thing related to this rotational dynamics, this circular motion of a body. So whenever I was discussing in the last class, I was actually discussing about certain things of moment of inertia, right? So you have to read all about the moment of inertia and the related things, like moment of inertia of a rod about its axis, moment of inertia of a plate, moment of inertia of a solid sphere, moment of inertia of a hollow sphere, that means you can refer it as a ring, as disk, and the kinetic energy, potential energy of in a comparative manner. You have to study in a comparative manner with translational motion and rotational motion. Like translational motion, mass is translational inertia, rotational motion, moment of inertia is involved with the angular moment of inertia, rotational inertia, like that kind of thing you have to understand. You have to understand the force equal to mass into acceleration from the converse of if you compare that translational motion and rotational motion, or you may refer this as circular motion also, right? So in this context, you can see that rotational motion translational motion are responsible for translational inertia, right? So whenever we go calculating force, this is called force, and we go on calculating this like force equal to mass into acceleration, right? In case of translational motion, right? But in case of rotational motion, we also calculate the force, but we can relate this calculation of force with the calculation of torque as well, right? Torque equal to moment of inertia into angular acceleration alpha, moment of inertia into angular acceleration alpha. So we can read this kind of thing in a very average manner, in a very competitive study manner, right? सो ये जब भी हम लोग पढ़ेंगे ना, तो इसको कैसे करना है कि ये इसको बिल्कुल ऐसे समझ लेना है कि हम लोगों को ऐसे कंपेयर करते हुए पढ़ना है, ताकि ज्यादा से जल्दी हम लोगों को समझ में आ जाए। तो फोर्स का तो ये निकल चुका है। अभी ये फोर्स को हम ऐसे भी कह सकते हैं फ्रॉम द न्यूटन्स laws of motion, that we can define this force as a rate of change of momentum as well, right? Rate of change of momentum, right? Now this angular momentum, we can also write it in the form of angular momentum, rate of change of angular momentum, right? So in this comparative manner, whenever we go on calculating the translational impulse, that is here, impulse can be calculated by means of what? By means of force into time of application of that force, right? Time of application of that force. Now what it will become, this is to be very specific, this is translational or linear impulse, we can say in a simple words, right? इसको हम कह सकते हैं कि ये लीनियर इंपल्स है। लीनियरली जब फोर्स लीनियरली एक बॉडी को हिट कर रहा है तो इंपल्स कितना होगा, राइट? सो दिस काइंड ऑफ थिंग आल्सो कैन बी कैलकुलेटेड इन टर्म्स ऑफ एंगुलर इंपल्स, राइट? So whenever we are going to calculate angular impulse में क्या होगा कि लीनियर इंपल्स में क्या है, उसका फोर्स और टाइम आ रहा है, तो एंगुलर इंपल्स में फोर्स के साथ इसको हम टाउ यानी कि टॉर्क को रिलेट कर रहे हैं, तो इसमें भी टॉर्क आ जाएगा, ठीक है। तो टॉर्क इनटू टाइम, torque into time, right? So this is kind of angular impulse, right? And all the relative formulas are accurately like that, like s equal to, that is the displacement, s equal to ut plus half at square, right? U is the initial velocity, a is the acceleration, right? Like that, a is the acceleration, t is the time, like that, and s is the displacement. Now this can be written absolutely like this. Here angular displacement will be there, right? And the, let's consider the initial velocity as omega naught, ut plus half at square. Here what we write, omega naught t half alpha t square, like this. And there is another kinematics related formula for linear or translational motion, like v square equal to u square minus u square plus 2as, right? Where v is the final velocity, u is the initial velocity, a is the acceleration, s is the displacement. So in this case we can write it as omega square equal to omega naught square, initial angular velocity. This is the final angular velocity, this is the initial angular velocity, omega naught square plus 2as was there, right? So we can write this by comparing that as 2 alpha into theta. Alpha is the angular acceleration, theta is the angular displacement, right? The live chat is there. If you are interested, you can put your views in the live chat as well, right? If you have any kind of question, any kind of interested, any kind of clarification, you want to clear it out by means of discussion, by means of clarification, you can really, I'll be happy to answer your queries, right? So it is highly appreciated, right? So that I can get the, okay, right? I will be delighted to answer your queries. Okay, so rotation about an axis is also there. So consider certain string is there and some rotation is taking place. So rotation about a moving axis, you can consider this also, rotation about a moving axis. So how this case be? So by studying this kind of thing, and much more formulas are there, I think you all have read about that, so I am not going to discuss it in detail, but let us study certain things like rotation about a moving axis, rotation about a moving axis. Okay, let us study this one, rotation about a moving axis. This case can be notified as a string is wrapped several times around a solid cylinder. Okay, let's consider this case. Let me draw this. consider this is be the cylinder, okay, of radius say r, right? Now this cylinder, a string is wrapped several times around this solid cylinder, right? The end of the string is held stationary. The end of the string is held stationary like this. This is the stationary end and this is the end of the string is held stationary, right? So now the thing is that the cylinder is released now. इसको थोड़ा सा सिंपल बना देते हैं, ठीक है? इसको थोड़ा सा सिंपल कैसे बना देते हैं? मान लो कि ये जो पॉइंट देख रहे हो ये तुम्हारा एक सिलेंडर है, ठीक है? अब इसको हम एक मतलब एक स्ट्रिंग से बहुत अच्छी तरह से इसको बांध लिया, ठीक है? ऐसे बांध लिया। मान लो कि ये एक स्ट्रिंग है, इससे हम ऐसे इसको बांध लिया several times, ओके? नाउ इसको बांध लिया। अभी ये स्टेशनरी है, अभी ये स्टेशनरी है, बिल्कुल बिल्कुल वो उसकी तरह। ये तुम्हारा स्टेशनरी एंड, ये सिलेंडर बांधा हुआ है, ठीक है? अभी इसको क्या कर रहे हैं? हम छोड़ दे रहे हैं, हम छोड़ दे रहे हैं रेस्ट के हिसाब से, तब हम छोड़ दे रहे हैं। अब इसको ये क्या हुआ? ये अनकॉइल होते होते यहां से, ये अनकॉइल होते होते यहां से गिर गया। तो ये जो अनकॉइल जब हो रहा था तब ये अपने खुद के एक्सिस के हिसाब से भी घूम रहा था और फिर it was also rotating along its axis as well as it was creating a translational motion in this direction, in this downward direction. Why it was a translational motion? Because in this downward direction it is working as mg, it is working as mg, right? इसका weight, इसका वजन काम कर रहा है ना, नीचे की तरफ इसका वजन काम कर रहा है, right? So as it is moving, okay, the chat option is currently active now. So if you want to have any chat, please do join. I would like to solve your queries, okay? I would like to solve your queries. Please do join. Just a minute. Please do join and share with your friends so that they can also be a part of this, right? So I'd like to share all your views, so it will be very easy for me, so please do join, and I will be it will be a
Share
great
with your friends so
great pleasure for me. Okay, so where I was discussing about this, that consider the weight is also acting on the here, right? But it is the tension that is acting upward. It is the tension that is acting upward, right? And a linear acceleration due to this weight, a linear acceleration is also taking place, as well as it is revolving about its own axis, right? So what is happening, the axis of rotation is moving. So this is the problem of moving axis, right? So the axis of rotation is moving. So we can easily form this question, can be seen from the point of view that वो सीधा वाला चलना बिल्कुल सिंपल सा, जो ट्रांसलेशनल मोशन है वो बिल्कुल सिंपल सा है। तो इससे हम लोग क्या कर सकते हैं, इसको हम एकदम सीधा कर सकते हैं। कैसे सीधा कर सकते हैं, सीधे वाला मोशन पहले लेते हैं, तो क्या काम कर रहा है, नीचे की तरफ mg काम कर रहा है, ऊपर की तरफ t काम कर रहा है, ठीक है। तो वी कैन टेक दिस एज mg माइनस टी इक्वल टू, तो इसका रिजल्टेंट मोशन जो है वो तो नीचे की तरफ है, राइट? इसका रिजल्टेंट मोशन जो है वो नीचे की तरफ है, तो वी कैन ट्रीट दिस एज एम ए, राइट? वी कैन ट्रीट दिस एज एम ए. So this is due to the linear motion, right? Now the equation for the rotational motion about this axis can be formed through taking under consideration the r as the radius of this cylinder. We can take this as t into r is I into a, alpha, I into alpha, right? That is the moment of inertia of the cylinder, and alpha is the angular acceleration. So the moment of inertia of the cylinder is, it is given as 1 by 2 m r square into alpha. We can get this, right? Now you have to consider that if the string unwinds without slipping, मतलब ये स्ट्रिंग जो अपने चारों तरफ से खोल रहा है, तो जब भी ये स्ट्रिंग अनवाइंड हो रहा है तो ये मान लो कि ये स्लिप नहीं हो रहा है, ये बिल्कुल एकदम रेगुलर से आ रहे हैं। अगर स्लिप होता है तो यहां पे उसका इफेक्ट आ जाएगा एम ए पे, राइट? सो वी कैन कंसिडर दिस एज the string is moving, right? Okay, so this string is unwinding and the cylinder is coming down. So the string is unwinding without slipping. We have to consider that the cylinder is not slipping down, right? The cylinder is not slipping down. Under this condition, this alpha will be this alpha, not this alpha, this not the angular acceleration, it will be the translational acceleration is going to be r into alpha, right? So from these two equation, this equation and this equation we can put this as mg minus half m r square alpha, right? m r square alpha. So it is becoming m r alpha equal to m a, right? So we can cancel this out. This m can be cancelled out from both the equations. By putting this value of t over here, we can cancel this equation right now. So the value of a, this is r alpha, we can put, instead of r alpha we can put a over here, right? So there is a and half a is getting added on, right? So this is going to be g equal to 3 by 2a, or in terms of a, it can be written as a equal to 2/3 g. A equal to 2/3 g. This kind of question you may face. And if a becomes 2/3 of g, then what is t becoming? T is half mr alpha, right? So that is half into ma. T is half m r alpha, that is half into m into a, right? And a is 2/3 of g, so half m 2/3 of g. This 2 is getting cancelled out, so this t is becoming 1/3 of g. So from here t we have also found it as 1/3 of g, and a we have found it as 2/3 of g. So both the linear terms are being calculated with avoiding the rotational terms. So this kind of question, this kind of sums you may encounter in your problems, right? Yes, one of my meritorious student is there, Ishan. Thank you, Ishan, for your comments. And I'll be all of your presence is highly appreciated. Thanks for presenting over here, and share as much as you can. Share as much as you can. Okay. And please do subscribe this channel. This channel requires your support so that I can take all through the other classes. Right, so this kind of problems you may face in your entrance exams as well. And another kind of problem is there. Let's consider a point mass on a string, owned on a, so there is a point mass which is wounded on the cylinder. So if such kind of thing happens, what will be that like? So before considering that kind of thing, let us do some interesting topic over here, that is MCQ type of problem solving. Okay, so this is the main attraction. and we will definitely going to return back to our theoretical concept development. But as you all know that reading a constant reading of theoretical physics is going to be very much boring, so let it do some practical practice that is some MCQ related problems, selected MCQ related problems over here. The first problems is the first problem is going to be from let us see the first problem. I think the problem is quite visible on your screen, so let us see the problem first. I think there might be some technical issues over there. I don't know. Okay, the issues has been overcome, I think. There was some technical glitch. You have to permit me for the technical glitch as well. So the problem is asking regarding a prism over there. Okay, the problem is asking regarding a triangular prism of mass capital M, right? Of mass capital M is placed on a horizontal frictionless surface of xx dash, that is the frictionless, consider that frictionless surface of xx dash, and uh, is released from a frictionless sloping surface of the prism. A mass m slides by length capital L on the slope of the inclination is theta. The prism would slide by a distance. Okay, so this is a, so the prism is there, right? So we have to find the distance as well. So anyone want to be a part of this discussion? The forum is open. If you like to answer this, you can answer in the comment section. Then I can help you to find the way of finding the correct answer. If anyone is there to find the correct option, then I welcome you to do that, right? Otherwise, I am going to solve that out, right? So there is a prism is there, triangular prism is there, right, of mass of capital M, and a body of mass small m is, a block of mass small m is released from the frictionless sloping slides by length L on the slope. So the length of this slope is given as L, right? So it is our duty to find the displacement, the distance moved by the block with respect to the mass m, how much distance it has moved, right? And it is given that this angle of inclination is theta, right? So this is L cos theta, and yes, obviously this is going to be L sin theta, right? I'm just changing the screen for your better identification, right? The screen is visible right now. Okay, so from here we can write, absolutely right, let distance moved by this block with respect to this capital M mass is, say, x, let, right? Now what will be this x? What will be this x? And it is also given that this is, say, x1, right? Now the total mass, the total system is moving with this component, right? Moving with this component, right? So we can get that as x2 equal to m L cos theta by capital M plus m, total system, right? Now what will be x1? x1 is L cos theta only, that is the movement, L cos theta with respect to m, with respect to m. So we can write this as x2 equal to m. So from here it is becoming, cos theta is becoming what? Cos theta is becoming x1 by L, x1 by L, then x1 is becoming what? L cos theta. So among the four given answer, you can easily detect this one is the right answer. This one is given as the right answer, right? So among the four given option, you can see that option B is coming up with the right choice, right? Okay, now let us see the next question. This is a question of another question from all India level of competitive exams. So you can refer this question as well, very important one. Okay, Tushan Mitra is also there. Thank you. Thank you, Tushan. Okay. So now you can see the next question, that is question number 2, is from, this is also a very important one. This is also a very important one where you can get the questions of so this question is actually taken from the concept that a stone tried to tied to the end of the string, just like this. You can say refer to the context, string of length 1 meter long, whirled in a horizontal circle with a constant speed. If the stone makes 22 revolutions in 44 seconds, then what is the magnitude of the direction of the acceleration? You have to understand the scenario first. What is the scenario actually? A stone is there which is being tied with a string, and it is kept, a stone is there which is tied with the string and it is kept moving. So this can be just a moment. Okay, I would again like to request you to subscribe this channel, क्योंकि अगर आप लोग सब्सक्राइब करेंगे तो I will get the support from your end. Yes, I will be very happy to answer your queries. I will be very happy to see you all, and I need your support badly to get acquainted with this. So please do support me by subscribing this channel. Your one subscription is very much priceless to me. Okay. So I am expecting your answer for this question. I am expecting your answer of this question. That is, the question is actually related to the stone tied with the end of the string of the 1 meter long, wheeled in a horizontal circle with a constant speed. Now, if the stone makes 22 revolutions in 44 seconds, then what will be the direction of acceleration? So whenever we are going to calculate the direction of acceleration, then the acceleration is related with the term of omega square r is the acceleration, right? Omega square r, this is the angular acceleration. So What is omega? We can relate this as omega as 2 pi into v, right? 2 pi into nu 2 pi 2 pi by t, or let me take it as 2 pi by t into r, since 2 pi by t is whole square, right? Now we can also take frequency of as 1 by t, so we can write it as 2 pi f whole square into r, and 2 pi is there, as well as f is 22 by 40, 22 revolutions in 44 seconds, 22 revolutions in 44 seconds, right? So this much of whole square into r is there, so this will be pi square meter, pi square r meter per second square, pi square r meter per second square, right? So this is going to be this is going to be this is going to be among the 4 given options. You can see among the 4 given options the calculation. I think you can see the calculation now. The calculation you can see, right? So the calculation is actually suggesting that among the 4 given options, option B will be the right choice, because acceleration is of 2 type. Let me clear this out. One is centripetal acceleration and another is radial acceleration, and the actual acceleration works in connection with that, right? So centripetal acceleration will not be present over there, so all the acceleration will be radial acceleration. So among the 4 given options, option B will be the right choice, right? Option B will be the right choice. Okay, so this was some kind of concept, and lot of persons are out there to support me. I need your support. Yes, please do subscribe this channel so that you can listen me carefully. Okay, so I think this will be very supportive for me. Please subscribe this channel and show your support. Okay, so this is from my end. In now time, I would like to inform you that this live session is going to carry out for long time. Okay, so I must share some very important things so that you find very easier to solve certain problems. Like, consider where I left. Let me take you towards that consider the problem of consider the problem of a dog is walking on a boat in still water. Okay, let me first clear this out so that it will be very easier for you and me to understand the problem very easily. Let me first clear this out, and after that I am going to solve this. Okay. So जिसको भी ये लाइव स्ट्रीम अच्छा लगे, सब्सक्राइब बटन को दबा देना है. And I am doing live regular basis, and I am taking this class for the sake of JEE and NEET aspirants. If you have any further interest to get connected with me, then you can connect in this particular given numbers below in the ribbon. Blue ribbon is there going on, blue scroll is going on, so you can hit that button as well. So this is a problem of dog walking on a boat in still water to establish a general formula for such type of problems, right? So ये क्या है कि एक डॉग है, डॉगी है, जिसको हम लोग क्या कर रहे हैं कि एकदम बिल्कुल नॉट ये बहता हुआ पानी नहीं है, फिक्स्ड पानी है, and a boat is there, right? A boat is there. एक नाव है और उस नाव में एक डॉगी है और उस नाव में एक डॉगी है. अब ये डॉगी क्या कर रहा है? ये डॉगी तो नाव में घूम रहा है, लेकिन प्रॉब्लम क्या है? प्रॉब्लम है कि इसका सेंटर ऑफ मास एंड डॉगी का मास. तो मान लो कि इस बोट का मास है m and the mass of this dog is small m, right? Let's consider this. And the velocity of the center of mass, we are considering it as 0 because it is the still water. It is the still water, right? Still water is there, right? So we can take this as the whole system is initially at rest. The whole system is initially at rest and no external force is acting on this system. कोई भी बाहर का कुछ भी फोर्स इस पे अप्लाई नहीं हो रहा है, तो हम लोग इसको 0 मान के चल सकते हैं, ठीक है? और फिर जब भी हम लोग इसको 0 मान रहे हैं, तो ये सेंटर ऑफ मास का जो वेलोसिटी है, सेंटर ऑफ मास का जो वेलोसिटी है, उसको हम कैसे निकाल सकते हैं? m v प्लस m v बाय m प्लस m. अब इसको थोड़ा डिटेल में बोलते हैं. This is the relative velocity, that is the velocity, individual velocity of the dog. This is the individual velocity of the boat, right? Boat, doggy. Okay. So this can be done that this is equal to 0, and we can find this as mv plus mv equal to 0, right? And we can also give it as m equal to dx1, that is the relative displacement of the dog. Dx1, relative displacement of the dog, is dx1 by dt plus m dx2, relative displacement of the boat, by dt equal to 0, right? Now, what is the negative sign? Where is the negative sign? अगर हम इन दोनों को, क्योंकि we can have the liberty to apply the conservation law of momentum, ये अप्लाई करने का हम लोगों का लिबर्टी है, ठीक है? Now if we are going to apply this, then this value is going to be okay. If you have any queries, you can put your queries in the comment section. Okay, you can put your queries in the comment section. I will be very happy to answer your queries. Okay, if you have any queries, you can put it in the comment section. I will be very happy to answer your queries. Okay, so this is going to be m x1 minus m x2, we can take this as equal to 0. Why is so? Because opposite, ये नेगेटिव साइन जो है, इसका मतलब है कि x1 and x2 has opposite direction, right? And x1 plus x2 will be your x relative. x1 and x2 will be your x relative, where you have to consider that x1 is the displacement of the dog and x2 is the displacement of the boat. So ये इंडिविजुअल का जो मामला है, ये एक इंडिविजुअल दोनों तरफ से चल रहा है. Okay, thank you for liking my channels, thank you for liking my live stream. I would like to request all of you, whoever liking my stream, please do subscribe my stream so that you can get the first notification for my next live, and do share with your near and dears so that I can have more enthusiastic feelings regarding hosting more live stream of such physics classes. It will be going on, just I have started today, like it is a 6:30 show, so it will be carried on like 6:30 show every day. You may join each and every time over here, and I will be very happy to answer your queries, right? So this kind of problem you may face, and from here you can be also asked to find this x1 and x2 individually. So how this can be calculated? So this can be calculated, x1 and x2 individually can be calculated in terms of, like, if we go on, x1 equal to x2, x relative minus x2, right? x1 plus x2 was x relative, so it can be done as x1 equal to x relative minus x2, right? Now let multiply the mass with the respective one, right? So what it will happen, so we can put it as m, it was given as, okay, let me clear this. इनिशियली कंजर्वेशन लॉ ऑफ मोमेंटम हम लोग इस पे ऐड कर सकते हैं, इसी इक्वेशन पे हम लोग कंजर्वेशन लॉ ऑफ मोमेंटम को ऐड कर सकते हैं, जो कि है m mx1, ये है mx1 इक्वल टू mx2, right? Now we can write, instead of x1 we can write this, so this will become m into x relative minus x2 equal to m of x2, right? Now from here, if we go on multiplying this, this will become m x relative minus m x2 equal to m x2, right? From here we can make this as m plus m x2 equal to m x relative, right? And from here x2 is coming out as m x relative by m plus m. This kind of problem you may face. This can be a dog, can be anything, can be a cart, can be a floating boat is there, and it may be some box of fishes, some any kind of problem will be there. The concept is this, the basic concept is this. So this is the way of finding out x2. Now what will be the case of x1, right? Let us see. So whoever is with me, please do subscribe to the channel, or your subscribe will share loves with me, and you will encourage me to do the next live stream. Thank you. Be with me. Okay, let's find x1. What will be x1? X1 will be, we can find this x1 and from that formula, it is let's change it as x2. x2 we can replace this, we can replace x1. Now if we change this formula as x2 equal to x relative minus x1, then the formula of this, that is m x1 equal to m x2 will become m x1 into capital M. Instead of x2 we can write this, right? That is x relative minus x1. So mx1 is going to be, I think it is visible to all of you. I think it is visible. If it is not, let me go to this section. Let me go to this section. This will be quite easier for you. I think this line is visible. Right. So this is becoming mx relative minus mx1, and cumulatively it is becoming m plus m x1 equal to m x relative. Therefore, x1 is becoming m x relative into m plus m. So this is the expression for x1 and this is the expression for x2. So all related kind of expression has been done over here, and the problem of a boat on a human on a floating boat of still water can be solved by this kind of problem, by this kind of situation, right? Here basically you have to make it very clear that how to calculate the center of mass velocity, the center of mass momentum, and where to apply correctly and properly the conservation law of momentum as well, right? So let us see, after this let us see the excuse me and sorry. So after this let us see the another part of this session, that is the interesting part of MCQ, right? So let us see the MCQ. The next question is all about this one. So I think you just read this MCQ, that is, it is summing up with okay. The quiz there, that is the moment of inertia of two rotating bodies A and B is there, is IA and IB. It is given in the question, and it is being asked in the question that what will be the kinetic energy, the relationship in between the kinetic energy. Okay, so it is quite tricky one. It is a standard, it has come in a standard exam of physics. It has come, and you can find it as also a very relevant one. This kind of question has been faced in 2015 NEET as well. So the moment of inertia of two rotating bodies A and B are IA and IB, where it is also mentioned that IA is greater than IB. So the moment of inertia of the body A is greater with respect to the body B, and if the moment of inertia are equal, then now look at this, the bodies are not mentioned by shape. That is the trick. You have to keep that in mind. Okay. So how the kinetic energy can be represented over here? That is the question. Anyone from from my viewers? You are free to answer. Anyone from my viewers? On the 4 given option A, B, C, D, anyone from my viewers can give the answer. Okay. Is there anyone? You can comment over here. You can comment over here. Anyone? Okay, let me do it. This is a very simplest one with the explanation of regarding remembering the formula for deriving the kinetic energy. The kinetic energy of a rotating body, kinetic energy of a rotating body can be given as E equal to half L square by I, half L square by I, right, where L is the angular momentum, I is the moment of inertia. Absolutely. So from there, as you see that as you increase this quantity, that is as you increase this moment of inertia quantity, the kinetic energy get decreased. That means kinetic energy is inversely proportional with the moment of inertia, So IA has lesser kinetic energy, has E and K of A is lesser than EK of IB, because IA is greater than IB, right? So you have to keep that in mind as well. Okay. So if you have any queries, as I always say, that it is a heartiest request to all of you that please do share this live among your friends, colleagues, and whoever is interested about this preparation, right? Your one share can make the difference, and your one subscription will encourage me a lot to do or to carry out the next live sessions. And your responses will be very much encourage me, so I require your responses as much as you can. Okay, so for the given question, you can see for the given question the kinetic energy of A is less than the kinetic energy of B, so option C will be the right choice. So option C of the given question will be the right choice, right? Please do subscribe my channel, and please be me. Your support will make the difference. Your support will encourage me to carry out this session in more interactive manner, right? So please do support this live session. Now let's go to the next question. which is actually asking that before going to the next question, okay, so let's go for it. The moment of inertia of a uniform semicircular disk of mass m of radius r. You can read the question over here. Let me check the social networking sites first. Okay. The moment of inertia of the question is given as the moment of inertia of the body is given as, so I would like to request all of you, whoever is seeing this, whoever is among this part, you're really and I'm very happy to be in you, and your queries will be highly appreciated from my end. Okay, so you can see the question given over here that the moment of inertia of a uniform semicircular disk of mass m and radius r about a line perpendicular to the plane of the disk through the center. So the disk is not a circular one, it is a semicircular one. So let clear it all. Here I mainly discuss with you different kind of problem solving techniques, different kind of problem solving ideas and different resources, so that you can get the opportunity to utilize this as well, this platform very well enough, right? My main aim is to help you out in this manner, right? So you can see the question. So the question is actually asking, so let us solve this first. If anyone is interested to give out the answer, you can comment in the comment section. So let's consider the disk is not the absolute circular one, it is semicircular. This portion is not present, right? So it is a semicircular disk, right, of say radius r, right, radius r. Okay, this is small r is there, radius smaller. So if the mass of m is the semicircular disk, if the mass of the semicircular disk is m, then as it is semicircular, the total disk has mass of 2m. It is quite clear. So what is the formula? That is half 1 by 2 m r square. Instead of m we have to write 2m, right? M, instead of m we have to write 2m. That is the moment of inertia. So this is basically m r square, right? Now what is this? Is the eye of total disk. You have to take in mind, this is the eye of total disk. So eye of semi circular disk will be m r square by half, because it is half circle, so it will be m r square by 2, right? So among the 4 given options over here, you can easily see, among the 4 given option A will be your correct choice. Option A will be your correct choice, right? So let's move on to another very interesting question, and that will end today's live stream. But before ending the live stream, I would like to request all of you, all of my viewers, to please do subscribe this channel and please support this live session. Those who are not able to attend different classes, different practice sessions, you can really get interacted with me through the live chat as well, which I have opened for all of you, right? So if you want to be a part of this live session, please do be with me and please join in the next live session, and do subscribe this channel. Your subscription will make the difference for the from the point of view of encouragement, right? So let's go to the next question, which will be the last for today. Okay, so the question is asking, you can read out the question first, and I am expecting this question, answer of this question from the audience. Answer of this question from the audience. I am expecting answer of this question from the audience. Okay, and I would like to request all the audience to be present with me and do subscribe this channel, so that I can get support to an encouragement from your end to carry out such sessions in future. Please do subscribe the channel. सब्सक्राइब बटन को हिट करना है और मुझे इनकरेज करना है कि आगे भी ऐसे क्लास जरूर हो सके. So please do subscribe this channel. Okay, so the question is all about an annular ring with an inner and outer radius of R1 and R2 rolling without slipping with a uniform angular speed. Now the ratio of the forces experienced by the two particles situated on the inner and the outer part of the ring, right? So for this particular purpose, let us try to understand the if you have any queries, you can put me here. Okay, let us understand this scenario first. So there is a annular ring of inner and outer radius. So how that will be look like? So the ring will be look like this. My drawing is not so proper. I hope you will consider that. So inner radius of R1, right? Inner radius is R1, yes. And the outer radius is R2. And there are two objects specifically on the inner wall, and another object is on the outer wall, right? Inner wall object and outer wall object. Inner wall object and let me big this screen. Inner wall object and outer wall object. Now how it can be manipulated? Okay, so this annular ring will be has a force of, each of the object will experience a centripetal force towards the center. Each of this object will experience a centripetal force towards this center, right? So for this particular purpose, say inner object, both of these objects have say mass m, this also have mass m. So the force experienced by the inner wall object, force experienced by inner wall object will be say Fi will be how much? Fi will be how much? M omega square R, m omega square, and this will be R1. And what will be the force experienced by outer wall object? That will be definitely going to be Fo equal to m omega square R2, right? So if I am going to take the ratio of F1 by F2, then the ratio is going to be definitely equal to m omega square R1, because omega will be same, mass is also same, so m omega square R2. So this ratio sustains as F1 by Fi by Fo, as this will be Fo as R1 by R2. So let us see the options given over here. Among the four given options, you can clearly see that option A will be the correct choice of this question. Option A will be the correct choice for this question. So with this question, this live session has come to the end, and before ending this live session, it is a humble request to all of you that your support, your wholehearted support by subscription, by commenting, by sending me queries will definitely going to encourage me a lot. Okay, in the next session it will be much more of regarding certain class 12 chapter. It may be from magnetism or electrostatics. I will see, I will let you know definitely by today night or tomorrow morning. And it will be another 6:30 show as you were expecting in the next day. So every day 6:30 show will be there, and I hope as much as you can share with all of your near and dears and your friends, your relatives, your others persons who really need such kind of classes. Thank you for your support. Do be with me and carry on cracking the concept of physics, because it is a class of physics live, of conceptual physics, right? So stay at home, be healthy, be knowledgeable, and always wisdom your knowledge. This is 𝙿𝚑𝚢𝚜𝚢 signing off for today. Let's goodbye.